Right. Assalamualaikum. Good morning, everyone.
Morning, doctor.
Morning, doctor.
Everyone is great. Okay. So today we resume our lecture. We're going to finish LU2, right? Um, so just to recap what we have learned last week, we have discussed about the fourth non-parametric test called Kruskal-Wallis test, right? So this Kruskal-Wallis test is used for analyzing non-parametric data with the conditions of more than two independent samples. Yeah. So before that, we have Mann-Whitney rank sum test, which is designed to analyze non-parametric data with two independent samples. Yeah, independent samples. If we go the weeks before that, we have Wilkinson sign rank test and also sign test. First one is sign test. So these two tests are for analyzing non-parametric data that are dependent. Okay, so that's the different, and that's the difference between the tests and how you're going to apply it for non-parametric data. Yes, I hope that you still remember what is meant by non-parametric data. Data that have a small number of size, and also if the data are ordinal or nominal. Okay, so by right you should know what are those things. Okay, so in this lecture we are going to discuss the final type of non-parametric test, which is called Friedman test. Okay, I have uploaded the lecture notes on Delete. So Friedman test, the difference between Friedman test and Kruskal-Wallis test is that Kruskal-Wallis test is only used to analyze samples. Let me rephrase. Kruskal-Wallis test is used to analyze only one factor, okay, related to samples of more than more than two independent samples. Okay, so the key thing here is the one factor. Okay, what is meant by one factor, let me explain later. But just to introduce you the Friedman test here briefly, Friedman test is used to analyze the effect of two factors. Okay, so that's the difference between Kruskal-Wallis test and Friedman test. So meaning to say that Friedman test is a little more detailed compared to Kruskal-Wallis. Okay, so keep that points first. Let's have a look what is meant by one factor and two factors. If we want to compare or relate Kruskal-Wallis test and Friedman test with parametric data, right? So Kruskal-Wallis test is equivalent to one-way ANOVA, and Friedman test is equivalent to two-way ANOVA. Okay, parametric data are those data that of higher number, more than 25. Let's say 50, 60, 70, 80, or 30. Yeah, so that one is like big number of data. That is called parametric data. Okay, let's have a look at the lecture notes. This is so the mid-semester exam will cover until Friedman test. Okay, LU1 and LU2. So this is the last subtopic of LU2. So it will be until today's lecture. Right, let's have a look at yeah, so basically what we will cover in this lecture, we will cover the introduction of Friedman test and also the steps for conducting the test. Okay. So what is meant by one and two factors just now? Okay, let me go a little backward. Let's revise Roscoe-Wallace and see the examples of the problems. Yeah? Let's go directly to the problem. Okay, so this is one of the example, right? In Roscoe-Wallace, last week's lecture. The problem is to compare 3 different methods of teaching German. Students are randomly assigned to one of the 3 methods and their exam marks are recorded in the table below together with the ranks of the marks. Okay. So what is the key point here is the 3 different methods. So this one, the methods of teaching German, that is the factor. That is the factor to be compared. Means that all the samples are compared in terms of the method of teaching German. Okay, that is the factor in this problem. And the way how the comparison, the comparison is made, you can see that method 1 has 6, right? 6 data or 6 points, 6 data. Method 2 has 7 and method 3 has 5, right? So the comparison is made throughout. I mean, meaning to say that method 1 compared to method 2. Method 1, the whole thing here is to be compared with the whole thing in method 2 and the whole thing of method 3. Okay, it's only one factor. Okay, so that is an example of one factor. Okay, let me explain with 2 factors. Let's have a look directly to the question so that you can see what is meant. Okay, this is an example of data with 2 factors. Okay, why it's called 2 factors? First, if you see the question, to compare the popularity of 5 politicians, the following popularity scores were obtained over a 6-month period. Okay, so if you see the table here, this one is actually referring to politicians. There are 5 politicians, and these are months. This is one. So that is meant by 2 factors. The first factor is the politician, the treatment. Normally, the first thing that we compare is called treatment. Okay, this is actually treatment. Okay, and the treatments are compared across another factor. Okay, the second factor, which is called block. Okay, so there are 2 factors. Remember, our first factor is normally referred as treatment, and the second factor is called block. Okay, so in this topic, we are going to refer the terms treatment and block. We don't say anymore first factor and second factor. Okay, so how to know which factor is the first one, which factor is the second one? So you have to see from, so if let's say in the question, okay, you depends on the question, right? Like in this case, it says that the priority here is to compare the data of 5 politicians, the popularity of 5 politicians. That is the first, the primary thing to be compared. It's not to be, I mean, the focus in this problem is not to compare the months, right? Because the months is actually comes after the politician. So that is how you can determine which factor is the first factor, which factor is the second factor. And that will help you to categorize which one as treatment, which one is the block. Okay, the reason why it's important to differentiate treatment and block is because you are going to apply the formula later, and they are terms for block and there are terms for treatment. So if you wrongly assign the label, so your calculation will be wrong. Okay. Right, let's have a look at another example, just to give you a better understanding of what is factor and what is treatment. Okay, in this problem, it is stated directly. Okay, if let's say it's not stated, so I go directly through the exercise, but later I'll go to the steps. This is just to introduce you the factors, the treatment and block. Okay, so in this problem, in a comparison of the prices of items at 5 supermarkets, 6 items were randomly selected and the price of each was recorded for each of the 5 supermarkets. The objective of the study was to see whether the data indicated differences in the level of prices among the 5 supermarkets. The prices are listed in the table. Okay, so you can see the table, it has the types of supermarket, and also the item to be compared from every supermarket. So this is item. Yeah. So how to know? It's not necessarily that the treatment will be the row and the block will be the column. You know, you cannot rely on that that factor. But how to determine between those two depends on the question, as I said. Okay, so you have to understand the question. What is to be compared in the first place? The primary or the ultimate thing to be compared. Okay, so in this case, if you see, this last two sentences, the objective of the study was to see whether the data indicated differences in the levels of prices among 5 supermarkets. So that's the emphasis, okay? And that is the treatment or the first factor. Okay, that's how you can identify the first factor or the main thing to be compared. The treatment is the first, why it is called the first factor, because it is the factor that the main factor that we need to compare. Okay, and the rest, like block, is actually secondary. Okay, that is how you differentiate it. Okay, so that's why I said it's very important to understand the problem. Okay, you just read carefully the problem, understand what is the thing to be compared. Okay, that is the main emphasis, and yeah, from there you can decide. Okay? So don't analyze the data without understanding the problem. And the problem is not really hard. Like in this case, it's just about comparing the supermarkets and the items. Okay. So if you don't understand it, you may wrongly assign the levels. So in Kruskal-Wallis, it might be not it's not as critical as Friedman Test because in Friedman Test you have to use the formula later. Yeah. So that's why you need to carefully identify the factors. Okay. Right. The introduction of Friedman Test for the randomized block design and non-parametric. Okay. This is a bit theoretical. So basically, Friedman Test is a test that is used to analyze independent samples with 2 factors. Okay, that is the easiest way to understand the Friedman. If you go for this one, it's quite theoretical. Understand easily. Okay, so Friedman test, just jot down. I don't have it in the notes here, but you can see that is a test, non-parametric test to analyze independent samples with 2 factors. Okay, whereas Kruskal-Wallis is used for analyzing samples with only 1 factor. Okay, so I hope that you understand now what is meant by the factor. Okay, that's the intro. Okay, so the main part is the steps of Friedman test. So there are some similarities with Roscoe-Wallace, especially on the Bonferroni inequality procedure, because now we are dealing with more than 2 samples, right? So as I said previously, when there are more than 2 samples, even if it's just 3, the minimum number, when you say that there is a difference in the samples, right? Let's say A, B, C. The next target is to find where the difference is. So it's not sufficient to say that there is a difference in the means of A, B, and C. You have to indicate more, or I mean, you have to investigate more where the difference lies. Maybe between A and B, but B and C are similar, because the alternative hypothesis says that at least one of the samples is different from the rest. Okay, or you can, yeah, that is one of the condition. Another condition is it could be all of them are not similar. Okay, but the first condition is also enough to say that it falls under the alternative hypothesis condition. Okay, so that's why we have to find the difference if we if in the middle of the steps we conclude that there is a difference, or we accept the alternative hypothesis. Okay, right, let's have a look at the steps. The first step is to set the hypothesis. Okay, so you have to mention all the samples. Okay, how I taught it for the Roscoe-Wallace. You have to mention for the null and for the alternative hypothesis. I think that's quite easy. And then the second step is to rank the data within each block. Okay, let's go through first the steps, and I'll explain later what is meant by that. And then the third step is to calculate the sum of ranks within the treatment. Okay, within the treatment. So please take note here, rank the data within each block. So unlike Roscoe-Wallace, you have to combine all the data and you have to rank from the highest, from the lowest to the highest, right? But for Friedman test, you just rank according to the block, which is actually much easier. So please remember that. But when you calculate the sum of the ranks, SI, okay, so it is within treatment, not within blocks. So these two steps is very important for you to understand carefully. Okay, right. The fourth step is to calculate the F. So this is the test statistics. So every test has its own parameter to be calculated. Yeah, for Roscoe-Wallace is different. For Roscoe-Wallace is what, H, right? For Mann-Whitney is U, and for Friedman is F. Okay, so this is the formula, and you can see the formula here. B is blocks, number of blocks. K is the number of treatment, right? And you have another term over here, B and K, right? SI is the sum of the ranks. Okay, so those B and K are those terms that you need to plug in correctly. Okay. Step 5 is to compare the F and chi-square values. Okay, so once you have calculated the F value, you have to find the chi-square value first, right? And then you have to compare the two values. Okay, the chi-square is the same table. I mean, you find the chi-square value from the table, from the chi-square distribution table, and it's the same table used for Roscoe-Wallace. Is it Roscoe-Wallace? Yeah, Roscoe-Wallace. It's not Roscoe-Wallace. I think it's Mann-Whitney, is it? Yeah.
Roscoe-Wallace is correct.
Roscoe-Wallace, yeah, okay, correct. So it's the same distribution table, yeah. And the rejection, the decision rule is to reject the null hypothesis if the F value is greater than the chi-square. Okay, so this is what you have to remember. And you find the chi-square based on the information of degree of freedom and also the alpha. Yeah? So it's the same thing as the Roscoe-Wallace, the step there. the chi-square. Right here means that here you make decision, yeah? So you know that whether you accept null or alternative hypothesis. So if you accept null hypothesis, it means that you don't have to proceed with the steps in order to find the difference. Meaning you accept null, there is no difference, full stop, right? And you make conclusion, there is no difference between all the samples. Okay, that's fine, the end. But if let's say here, at this point, if you accept the alternative hypothesis, means that you have to find next which pairs that has the difference. Okay, so means you have to proceed with Bonferroni inequality procedure. This is the steps after step 5 just now. 6 and 7 are called Bonferroni inequality procedure. So it's the same thing like Kraskowski's. Yeah, but this one, the critical value formula is different because it has B over here. So this one you have to take note. What you have to find out or what you have to solve under Bonferroni inequality procedure. First, the sixth step is to find the critical value. This is the formula, yeah, z equal to square root of, critical value is equal to z multiplied by square root of bk multiplied by k plus 1 divided by 6. Okay, so how to get the z? You got it from the tail area of alpha divided by k times k minus 1. Okay, so this one, CV is equal to the whole thing here. Means that the z is included in the formula. Okay, last time we find the z value, right, for the Kraskowski's, and we define z as the critical value. But this one, the CV is equal to z times by this expression, and z is included in the formula, in the term. So once you find the critical value, you have to compare the CV with the SI minus SJ value for every pair. The same thing how you do for the Kraskowski's, right? So you have to match every treatment with another treatment. Okay, so that's creates SI minus SJ, and you have to take note on this symbol. The absolute value means that it should always be positive values. Yeah? So what happens if you forgot the absolute value or the bar symbol? You might get the negative values, and when you compare this with the positive value of CV, of course it will be less. Then your decision might be wrong then. So it should be positive values of the difference between SI and SJ. Okay, so here means that you will have a number of decision depending on the number of pairs that you have, right? And the decision. Okay, so decision. So after you complete step 7, step 8 is to conclude which pairs that have and which pairs that do not have the significant difference. That's on the decision. Means that if the decision rule is if SI, the absolute value of SI minus SJ is greater than the critical value, then you reject the null hypothesis. So based on that, you make the conclusion in step 8. Okay. So you have to mention both conditions, which pairs that have the difference, which pairs that do not have the difference. Okay. Right, so that's all the steps for Friedman test. Okay, let's have a look at the examples. Before that, any question? No question? Okay, let's have a look at this question. So you are given this data and you have to test whether there is any difference in the popularity of 5 politicians. I think this sentence, this problem is not, the sentences are not complete. So basically, you have to find between all the politicians whether there is a difference in the popularity, but based on blocks, based on month 1, month 2, month 3, month 4. So it means comparison here is based on, let's say here, month 1, between A, B, C, and D and E. Okay, and then the comparison goes on, month 2, and so on. So if you remember Croscoe-Wallace, it doesn't have the block. So it means that you compare the whole thing of sample 1, sample 2, and sample 3. Okay, so that's the difference. So what is the benefit of the data with this type of style, the one with block? It is more organized. And if you want to practice later in your research, it will be much easier actually to compare, because you have another basis, not like one here serve as the basis of comparison. Okay. Okay, so what you should do, the first step is to set the hypothesis. Step 1 is correct, isn't it? Shouldn't be. It should be more specific. All politicians. It's correct in your slides, in your notes. To correct that. Okay. So whenever you write the hypothesis and also the conclusion, please be specific based on the problem that you analyze. Don't say all samples. I mean, yeah, that's fine, but then it would be much better if, like in this case, you refer back to the question. Yeah, we are talking about politicians, right? So just mention it specifically. So because this will what you have to apply later in your research when you understand what you are doing, but when you report it, okay, when you try to tell people to write and to report, we do not know what is actually meant by sample 1, sample 2, sample 3. You should say sample 1 maybe Kuching area, or maybe Kuching, sample 2 Samarahan, sample 3 Cebu. So that will be more clear, right? Rather than if you just name it A, B, C, D, 1, 2, 3. Yeah? So it should be specific to the problems. So that's why I like to emphasize from this course, because this is what you will apply later in your research in your FYP later, because you will use statistics to analyze your data. Okay, step 1 is to set the hypothesis. All politicians have the same popularity, means there is no difference, right? And for the alternative, at least one politician differs in popularity from the others. Okay, here you can see that it is in the form of sentences. Yeah, you can have like this, or you can put the expression. Okay, but this one is actually much more proper, because let's say in your report, you should write it in proper sentences. So that's why this one is more preferable. Okay, step 2, if we revise back the steps here, step 2 is to rank the data within each block. Yeah, and then step 3 is to calculate the sum of the ranks within treatment. Okay. So how to apply these 2 steps? Right, so this one is block, right? This is block, and this is treatment, which is the politician. So we have to rank within the block. Yeah. So if we go back to the original data, what is meant within the blocks? So we have to rank from the lowest to the highest. Okay, but now we focus on the block by block. So here, if you see month 1, the lowest number is 1, right? 11. So that is the first rank. The second rank is here. The third is here. Fourth is here. And 5 is here. And the same thing you do for every other block. Yeah? like this one, okay, you can see that this is the same, right? This is type ranks, it should be assigned. So 1 and 2, the type rank divided by 2 is 1.5. So this one should be 1.5. Okay, 1, 2, because 1 and 2, 3, the next rank should be 3, 4, and 5. Okay, and for this one, it's 1, 2, 3. Okay, this one is 4 and 5, supposedly it should be 4.5, right? Okay, and you do the rest for the rest. So it means that you rank within blocks. That is meant by within blocks, and it's actually much easier compared to classical bodies, whereby you have to rank throughout the whole data, which is a bit tedious. Okay, that is ranked within the blocks. Okay, so these are the results over here. You can see the same. This is the ranks. And the step 3 is to calculate the sum of the ranks. It's not sum of data. Please be careful. So what you have to sum up is the sum of the ranks. Okay, let's say this one is the ranks, and this is treatment. Yeah, each of this column is treatment. So the sum of the ranks within the treatment means you have to sum up 4 plus 3 plus 3 plus 3 plus 3 plus 3.5 is equal to 19.5. And you do for the rest as well. Okay. And don't get confused. Don't rank. Don't sum up the value. It's not 20 plus 18 plus ni. So it's the sum of the ranks. Okay. So that is step 3. Step 4 is to calculate F, right? Calculate the F. So that's the formula. So step 4 is to calculate the F value based on this formula. Okay, now B is what? What is the value of B? B is what?
6.
Yes, B is 6. K? Number of treatment? 5, yeah. So those values that you need to plug in into here. Okay. So the expression here is, so this one is the summation, right? Yeah, this one. So it means that once you get the sum of the ranks of every treatment, you square it, yeah, put it in the bracket so that you know that it needs to be multiplied with this term. Yeah. Right, and then 6, 5, and the value here is 18.33. Okay, when you write this kind of long expression for formula, be careful with the terms and make sure that you write it, you organize your workout so that you don't get confused, you don't miss the information, and you have to avoid the careless mistakes. Right, so that's the F value. So the next thing is to find the chi-square value, right? Chi-square value based on the information k minus d equal to k minus 1. So that's 4, right? And then the alpha. Okay, alpha in this problem is 10%, which is equal to 0.1. And it's given. If it's not given, then you have to find by yourself. And let's have a look at the chi-square table. So the value that you have to find is 7.779, isn't it? Because B is equal to 4 and alpha equal to 0.1. Okay, 7.779. So that's the value that you need to compare with this. Yeah? And you have to compare with the F value. Right, so the F value is greater than the chi-square value. This is chi-square value. So we have to reject the null hypothesis and conclude that at this point, this is not the final conclusion yet. Okay, you have to proceed with the Bonferroni because you reject the null, right? You have to conclude that the politicians are not of the same popularity. So hence, you have to need to find the difference. Want to find the difference? Proceed with step 7 to step 9. Step in this case is step 6, I guess, yeah, 6 to 7, yeah, 6 to 7, which is the Bonferroni inequality procedure. Okay, so step 6 is to calculate the critical value. So this is the formula. The value equal to Z multiplied by BK, K plus 1, square root of K divided by 6. Okay, everything here is you have already the info, but except Z. Okay, you need to find the Z. So how to find the Z? First, you have to find the tell area first. The formula, this one is the same as in the Croscoe-Wallis test. Yeah, find this area, this tell area, which is equal to alpha k minus 1. Okay, alpha is given as 0.1 in this problem. K is 5. Yeah, 5 minus 1. So what's the value? So what is meant by the tell area? When you sketch the normal table, yeah, is the tell region here, 0.005. Okay, so this is 0.005 tell area. But in order to find the Z value, you cannot depend on the tell area. You have to find the area from the 0 axis. Yeah, this X area. So we know that the total area of half of the distribution is 0.5. So 0.5 minus 0.005 is, I hope you get what I mean here. You don't have to, I assume you understand already here, is 0.495, the area, okay? So based on that 0.495, you find the Z value. Okay, let's have a look at the Z table. Z table, okay, 495. So the way how you find it, because inside here is the area, the Z is the first column, you can see, right? So find 0.495, the nearest value, that is 0.495, which is this one, yeah, is between 2.57 and 2.58. If you round up, it will be it's actually in the middle, 2.575. So you round up, it will be 2.58. That's why you take the bigger value, okay? So the Z value is 2.58. Huh? So this Z value is 2.58. And this is the value that you need to plug into this formula. And that's how you get the critical value. Okay, now that's the critical value. So the next step, or step 7, you have to compare the critical value with this term. Okay? So it means that you have to create The easiest way is you create like a table now. Okay. SIJ. Okay, we have how many treatments? 5 treatments, A, B, C, D, E. Okay. So how you create it? You have to find what is SA minus SB, the bar. SA means that you just match one by one. What I mean, create the possible parts. Yeah? So SA, SC, SA, SD, right? And then SA, SE. S, BC, S, B, it's a bit long because you have 5. C minus SE, C minus SE. Hope you understand what I'm doing there. SD minus SE. Okay. Okay, make sure you check lah. Bila you buat ini, you check lah. Betul ke tak apa yang you buat. SA, SB, AC, AD, AE, BC, BD, BE, and CD, CE, and finally DE. Okay. The order is not important. That means that macam you just go from one side lah. BC is equal to CB, so you don't have to find CB plus. Yeah? So BC is enough. Right. So here, remember in the previous tabs you have find what is SI, right? SIA. This is SI. This is I is referring to just to denote the treatment in general. Okay. So if you have the data already, you can say according to the data, like this one SA, SB, yeah. Don't get confused with I. SC, SD, SE. Yeah? So it means that your SA is 19.5, 25. Let's write it down. 19.5 minus 25.5. And you plug in all the values according to the values of SA, SB, SE. Yeah? Right. So this value, for example, so here is supposed to be 6. Yeah? SASC. Any questions so far? I just copying the values. 26, 7.5. 6, 7.4, 11.5. Okay. So you sorry value for each of this 19.5 minus SC is 26. Let's say 6 minus 6.5. Okay. Still see, I couldn't see that. So don't forget, there's no negative value of this one, this thing. So you do for the rest, okay? And the next step is to compare these values. So remember the CV values here is roughly CV value is 14.07. Okay. I just want to write this one because the one that is on the slides is a bit messy, which I don't like. So I like this. The way here is actually much more easier for you to remember, right? CV is 14.07. So you create another column, put the decision. So you have to say whether you accept or reject the null hypothesis based on the comparison between the CV and the absolute value of Si minus Sj. Okay, based on the decision rule. If the Si minus Sj is more than the critical value, reject the null hypothesis. So this one is accepted. Accept the null. So you will have this kind of things, the values of the Sij for every pair and also the decision. Okay, so that is step 7. Step 7. So what is meant by accept and reject the null here? You can say that between, if let's say it's accept null, so means there is no difference, right? There is no difference between A and B. If you reject the null, means that you accept the alternative hypothesis. So there is a difference between the two pairs. So that information are needed for you to make a conclusion at the end. Okay, so these are all the steps. So see here, reject. So the conclusion here, step 8, you have to write at alpha equal to 10% for this case. There are 3 pairs that reject null. Okay, or you can say there is a difference between pairs C and D, C and E, B and D, and there are 3 pairs, namely this one, and this one, that do not have differences in their means. Okay, so meaning to say that conclusion, you have to indicate pairs that have difference and pairs that do not have the difference. Both conditions should be stated. Okay, it's a bit lengthy, yeah, I know, but you have to state all the pairs. Don't skip or don't simplify it. Okay, so that's how you solve using Friedman test. Okay, so if you see here, the methods here is a bit messy. I prefer the way how you grade it is like this, that you make a table and then make a decision next to it, and then from there you can see the condition, yeah, the decision that you make for every pair. Okay. And also, if you see this slide, I just do not want to delete it because just to standardize the slide with other groups. But this one, order the total ranks, this is optional. I put it, this right in your slide. It is optional. I don't really emphasize it because to me, what's the most important is the decision for every pairs. That is actually more important. The order, I don't know why they create it. I don't see the relevance of it, but this one is optional. This step. This right? Yeah? Because I don't put it in the lecture notes that I uploaded. Okay, so that's basically what the steps are. Right. The most important thing is it's a bit similar to crossword words, but you just have to take a note on the formula because it has B. Yeah? Right. Any question? That's the examples that we discussed. The rest here are exercises for you to solve by yourself at home. Any problem? Any problem? Any question for Friedman test before we disperse today? bit tired today, I'm sorry, because I have a class before.
Excuse me, doctor, may I ask?
Yes.
Do we have any how will the final exam, will mid-semester exam be carried out on ELIP exam, or and will there be any multiple choice questions, or will there be long answer questions?
Yeah, okay.
Thank you,
So
doctor.
basically, okay, thank you for the question. I just asked the coordinator. So she said that I'm not sure about the MCQ and the short answer question, but for sure, long question are included. Long questions mean like the same type of questions that you did for tutorials. That is, we refer as long questions, calculation. That one for sure, yes. But MCQ, and because before this we do have the MCQ, but for this time around, the coordinator said that she will inform later. Yeah, it could be yes, it could be no. Yeah, but for sure the long questions, the calculation, it is included. The exam will be conducted on exam ELIP. Are you familiar with exam ELIP? You have used the system, right? Last semester?
Yes, last semester, doctor.
Yes.
Yes. So I will post the information about it, like but you know about exam ELIP. So you log in into the system, and you will see, you just search for the course code for this course, STF. Oh, sorry, this is the wrong code, and not this one. STF 1153 for biostatistics. This one is the old code. Yeah, you search for it and then just go through there, and you are required to first submit declaration form. Yeah, you just read the information, the instruction from there, and you will just go the flow, just follow the flow from there. Yeah, so but basically it's on the exam ELIP. Any more?
Okay, thank you, doctor. Do you have any spoilers for the upcoming exam?
Anyone?
Spoilers.
Spoilers? Spoiler, I would say every test has question. every test has question. Yeah. I think if you do well in your tutorials, yeah, even though it's a group assignment, it's a group task, but if you participate, you know why you answer that. Okay, means that yeah, you know how to solve it by yourself. Yeah, even though you submit it in a group, you'll be fine, I guess. I mean, because the type of question is similar. I mean, the way how the questions asked. And as I said, if you follow what I was saying, like conclusion, you have to state what is needed. Yeah? So you would get full marks on it. Statistics is very easy to get full marks because the answer is only one, actually. Okay, any more? The
Also,
formula
doctor,
even-
is it? Pardon?
Yes,
Sorry,
yes, yes.
sorry, go ahead.
Is it what? No, it's mine. It's not.
Sorry, go ahead.
What do you want to say? No, just go. You go ahead.
All right, may I ask if is it okay if we write our answers down on paper and then scan just in case? Is there a format?
Sure. Yes, you don't have to type because if you type, it will take time, right? So what you have to do? Okay, I forgot to mention that. What you have to do? You just write normally on A4 paper, okay? But at the end of the exam, you have to scan it and make sure you scan it correctly, clearly, and you don't miss any page, because I'm not going to be responsible if you miss any page. That is your responsibility. So please, if you want to rehearse how to scan, find the nice app or the best app to scan. Okay, that would be better if you do it beforehand. Yeah, that is digital things. At this age, at this point, you are expected to know that by yourself. Yeah, I'm sure you know more than me. Yeah. Okay, but the key thing is you just write on normal paper. Just write using normal pen, yeah, just write as usual, but you scan the things and compile it, save as PDF. PDF means that I cannot change it. If you change, because PDF is I mean is in a form of can't be altered. If you put it in a Word file, you may put it, let's say, you scan the things, that one is a scan, and then you compile it, maybe you paste it on Words, maybe, and then you convert it into PDF. That is the most important part. The last part is to convert it into PDF. But because if you put it in the Word file, it means that if, let's say, I download, I can edit it. Yeah, I can just maybe miss out of any of the answers. So it's not in the way that can't be altered. So that's why PDF is preferred for the final format. Okay, but make sure you compile. I don't expect to download page by page from one person. So I just expect to download the whole file that consists of all your answers. Okay, so that's why you have to practice beforehand, because I'm sure that within that 3 hours is a bit rushing and it might be panic. Yeah, so make sure you know what to do, how to scan, how to compile, how to convert to PDF. And then I leave it to you. Okay, the formula will be given, but as I said, you have to know how to use it and when to use it, because we're not going to tell that this is for Friedman Test, this is for Glasgow-Wallis. So you should know F for Friedman, H for what. Yeah, that one is you need to know by yourself. And how to use the table. Okay, refer to the right column, row. What else? Yeah, alpha value, if it's not given, you have to define by yourself. Yeah, but please make sure you write it like alpha equal to what, so that I know it's based on what. Because the answer can be, if let's say the alpha is not given, I can accept answers for alpha equal to 0.05 as long as the alpha is defined. It doesn't matter 0.05, 0.01. Sometimes people use 10%, which is 0.1, also fine. As long as you state it, I know it's based on what. Okay, so it's not just that I accept 0.05. But if it is stated in the question 0.05, okay, the one I have to accept only for 0.05. So I cannot accept for other alpha values. Okay. What else? Right. So now you can just complete your tutorial 2 and submit as soon as possible, so that I can give feedbacks before the exam. Inshallah, I'll try my best. Okay. I have marked your tutorial 1, so I will upload the mock tutorials on Elite today, inshallah. Tutorial 1 tak ada masalah sangat, because it's just about basic theory and some theories. Tutorial 2 is the one that you should perform lah. I mean, you have to know how to do it, because that's the things that will be asked in the exam. Okay, any more questions before we disperse? I'm a bit tired today. I have 2 classes back to back, and I'm fasting. I'm really, I feel so thirsty now already. Okay, have a nice day, and
Doctor,
all the best for the exam. Any more questions? Yeah.
Doctor, what about the attendance?
Okay, I will post one question, and you have to answer it on Elite. Okay, so that it will help your revision as well.
Okay, Doctor.
Okay.
Thank you.
Okay. All right. Okay. Have a nice day, everyone. Thank you for your attention. All the best for the mid-sem exam. Anything I will just update on Elite and Telegram. Okay. All right.
Thank you, Doctor.
All right.
Doctor.
Welcome.